Greetings and welcome to another VMBlock screencast. In this screencast we're going to continue to take a deep dive into the Liquity protocol, and today we're going to focus on the oracles that they use, how they get their price feed into Liquity protocol, how they handle the different oracles and fallback mechanisms, how they handle a broken oracle and a frozen oracle, and how they recover from such situations. So without further ado, let's get started. So, Liquity oracles. We're going to cover about the Liquity oracle logic. We're going to look at broken oracles and frozen oracles. We're going to look at what happens if both oracles are failing, and we're going to see how did Liquity solve this problem to recover from oracle failure. So a bit of background information. Liquity utilizes a price feeding mechanism using a dual oracle design. The system has what they call a primary oracle, which is Chainlink, and a secondary oracle, which is from Tellor. And the secondary oracle is essentially their failover oracle. So if the primary oracle is failing, then they fall back to the secondary oracle. Now there's a sophisticated logic for switching from one to the other should they fail. So this is if the primary oracle fails, there's sophisticated logic to switch to the secondary oracle. The intention of this is to give Liquity a high chance of always seeing an accurate price for ETH. And it also allows to swiftly return to the primary oracle once it's working again, and all of this without any human decision making or action. Now, before I proceed to the next slide, I'll just show you very quickly the two oracles that Liquity are using, so Chainlink and Tellor. So here's the Chainlink website, and if we want to take a look at their products, we can see that they have market data and data feeds. So this is what they are using, and we can look at the different data feeds over here. And Liquity are using this price feed, the ETH USD price feed, and basically this is a aggregation of a number of other oracles all pulling in the data at the same time and then averaging that out and giving you the current price of ETH. There's a few things here which we're going to cover, things like the deviation threshold, which is what Chainlink uses for determining when to submit another price. So this is the Chainlink Oracle data page, and the other Oracle that's being used is Tellor, and you can check that out at this website here. So I'll link to these oracles in the show notes. So back to the slides here. What is the oracle logic used by Liquity? Let's have a look. So basically, the way that Liquity gets the price from these oracles is to call the oracles each time the system needs the ETH price, and it calls both oracles. So if you recall in Liquity, one of the things that you can do is open a trove, and this is to basically create a position where you have some collateralized debt and you place in some Ethereum and you get the LUSD back from the trove. And in this case, when this action happens, when you initiate this action, Liquity smart contracts will fetch the price from both oracles at this moment in time. The Liquity smart contract also keeps track of whether or not the oracle is working, frozen or broken, and we're going to define what these states are. And it's going to prefer the primary oracle for the current ETH price, and it will use the secondary oracle if the primary oracle fails or freezes. Again, we'll look at what this means to be fail and freeze. If both oracles are frozen or broken, then the last good price that the system has seen is going to be used. And in the case of a primary failure or freeze, then it's going to keep checking both oracles and switch back to the primary when both are live and in sync again. So what is a frozen oracle? What does this mean to be frozen? Well, under normal conditions, Chainlink updates its price whenever the ETH price deviates by 0.5%. That's what we saw in the UI just now. Or it will update the price after at least 3 hours. Now, under these working conditions, Chainlink typically will update the ETH price several times per hour. This is because, of course, the price deviates by more than 0.5% in the hour multiple times. And Liquity will consider the Chainlink Oracle frozen if it hasn't updated its price for more than 4 hours. So if Liquity hasn't seen a price update for 4 hours, it considers the Chainlink Oracle frozen. Now, in the unlikely scenario where the Chainlink Oracle doesn't update the ETH price within 4 hours, then Liquity will detect that and switch to the secondary Oracle, which is Tellor. In this case, Tellor operates a little bit differently to Chainlink, where the price is only updated after Tellor is tipped and miners submit price data. So obviously, when Liquity is using Tellor as the secondary Oracle for its price feeds, the logic for getting that price has to be a little bit different. And this is something that we can cover in a different screencast where we might go into how Tellor works. But for now, we just have to bear in mind that Chainlink and Tellor operate slightly differently, but under the hood, this is handled by Liquity smart contract. So a little bit more on the broken Oracle criteria. So there are a few ways an Oracle can outright fail. One is that there's no response when called by Liquity. Another is that the timestamp of the response is invalid. For example, it's a 0 or it's in the future. Or the return price is 0. In all of these conditions, Liquity will deem the Oracle to be broken. When Liquity is using the primary Chainlink Oracle, it checks if the price deviation between the two price updates. Now, if the difference is greater than 50% between two price calls, and the Tellor price doesn't match this new price, then Liquity considers the primary Oracle price to be incorrect and switches to use Tellor. So you can imagine that there is a big price difference between two consecutive calls to Chainlink, the primary Oracle. And then if that difference is greater than 50%, then it's either a very big market swing or there's something wrong with the Oracle. And that's why Liquity checks the price in Tellor, and if it doesn't match, then it will consider the primary Oracle to be broken. And just as mentioned, if Tellor price does match, then it means that the price is indeed inferred to be correct from Chainlink, and that this is a legitimate market movement. So how does Liquity recover from a double Oracle failure? Well, so in the extreme and unlikely event that both Oracles fail, Liquity will use the last good price seen by all operations. This effectively freezes the price used by the Liquity protocol. However, Liquity does still try its best to recover and switch back to the primary Oracle when it comes back online. But this presents another challenge. How can Liquity switch back to the primary Oracle when it comes back online? So after a problem with the primary Oracle, how does it do this? Well, let's imagine the primary Oracle goes live again and resumes serving valid current price data. The mere fact that it's live again does not guarantee that it's serving accurate data, and there's a reason, of course, to be suspicious of new price data for an Oracle that was just frozen or broken. Now, of course, off-chain, we can investigate the situation and we can check market prices and talk to the developer team and auditors to evaluate whether the Oracle is in fact working properly. But on-chain, without an admin or governance process, there is no way for Liquity to manage and manually reapprove the Oracle. So how does it do this? Well, the solution is in the smart contract code. What Liquity does is to return to the primary oracle only when both oracles are live and are serving a sufficiently similar price. That is less than 5% difference. Now this logic works because the chance that both oracles are serving the same incorrect price data is very low. So if they're both live with in-sync price data, then Liquity can infer that both oracles are in fact serving the real market price, and therefore it switches back to the primary oracle. So this is a very elegant solution that Liquity have put together, and it's all written in the smart contract code. The great thing about Liquity is it's fully open source, and you can check this smart contract code to see exactly this logic implementation. So finally, conclusion on Liquity and in particular the oracles. So Liquity is intended to function for many years to come with no human control or intervention. Therefore, it needs an accurate and up-to-date ETH price and resilience to oracle problems. The dual oracle design with fallback and recovery logic gives the system a fighting chance in the event of an oracle glitch or even a critical failure. So the design of the oracle system in Liquity is definitely something to check out, and is a great example of how you would use oracles in a decentralized non-governance system such as Liquity. So I advise you to take a look at the source code, take a look at the smart contracts, and of course play around with Liquity to see how that works. Also read up a little bit more on Chainlink, oracles and Tellor, and I will see you in the next screencast. Take care.